Let's talk about approximating areas under curves using Riemann sums. Estimate the area between the graph of f of x equals x squared plus 1 and the x-axis. For 0 less than or equal to x less than or equal to 2, use 4 equal subintervals. Huh? Well, what's this 4 equal subinterval stuff? Well, here's the idea. We want to estimate the area between this curve and the x-axis. I'm going to use 4 equal subintervals to do it. So this, and this. Here's how we'll do it. We're going to draw lines from the x-axis to the curve, and then we're going to use the right end point of each interval to construct a rectangle like this. So we end up with these 4 rectangles. Now the area under the curve is approximately equal to the sum of the areas of the rectangles. So let's go ahead and calculate the areas of these rectangles. The first rectangle, for example, is going to have height. Well, notice what the height is. These are 4 equal subintervals, so this is 0.5, this is 1, this is 1.5, that's 2. Again, the interval has width 2, and there are 4 subintervals, so each has width 1/2. So the height of this rectangle is going to be the y-coordinate at x equals 0.5, and that's just going to be f of 0.5. So the y-coordinate is just going to be f of 0.5, whatever that is. And the width is going to be delta x. In this case, that's the width of each interval, which is 0.5. So the area of this first rectangle is going to be f of 0.5 times delta x. The area of the second rectangle is going to be the height of this segment. In this case, that would be f of 1. So the height is going to be f of 1, and the width is again going to be delta x. The height of this third rectangle is going to be f of 1.5, and the width is delta x. And the height of this last rectangle is going to be f of 2, whatever that happens to be, times delta x. So here's what we end up with. Okay, now let's factor out the delta x. So we get f delta x times f of 0.5, f of 1, f of 1.5, f of 2. But we know what f of x is. F of x is x squared plus 1. So f of 0.5, for example, is going to be 0.5 squared plus 1. F of 1 is 1 squared plus 1, f of 1.5 is 1.5 squared plus 1, and f of 2 is 2 squared plus 1. Calculate this, we get this, multiply it out, blah, blah, blah. We end up with 5.75. So that is our estimate for the area under the curve. Some authors call the endpoints of the subinterval the grid points. In this case, they'd be 0, 0.5, 1, 1.5, and 2. Those would be the grid points. Sums of this form, f of x1 delta x plus blah, 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 f sub x, f of xn delta x, those are what we call Riemann sums. So this sum, for example, would be a Riemann sum. Is this an underestimate or an overestimate of the area under the curve? Well, let's look at our sum. Okay, notice that we counted this stuff over here, and this is stuff that we should not have counted. So our estimate is going to be an overestimate. We counted things that should not have been counted. Let's do another example. There's no way you're going to get it from just one example. Estimate the area between the graph of f of x equals square root of x plus 3 and the x-axis for 1 less than or equal to x less than or equal to 6. Use a Riemann sum with 5 equal subintervals. Give an answer accurate to 3 decimal places. Okay, so here's our curve. We're estimating this between 1 and 6. And we want to use 5 equal subintervals. Well, the interval has length 5, so 5 equal subintervals, those will each have length 1. So let's draw these rectangles. And again, from the right end point of each subinterval, draw a line across to the left. So we end up with something like this. Okay, there we are. So let's approximate these areas using Riemann sums. As before, so again, the height of this rectangle is going to be the y-coordinate at this point. Since the x-coordinate is 2, the y-coordinate is going to be f of 2. So, and this is, so the height is f of 2, and the width is delta x. Now in this case, delta x is 1. It's not a half like it was earlier. So the area of this rectangle is going to be f of 2 times delta x. In the same way, the area of this rectangle is going to be f of 3 delta x. The area of this rectangle is f of 4 delta x. The width of this one is f of 5 delta x. And lastly, the width of this one is f of 6 delta x. That's what we end up with here. As before, factor out a delta x, we end up with this. We know what f of x is. F of x is the square root of x plus 3. So f of 2 is the square root of 2 plus 3. F of 3 is the square root of 3 plus 3, etc. All the way up to f of 6, which is square root of 6 plus 3. When we evaluate these, we get delta x, which is 1, times square root of 5 plus root 6, root 7, root 8, root 9, and that ends up being 13.160. So that's our estimate. What are the grid points? Again, again this would be 1, 2, 3, 4, 5, 6, left and right end points of intervals. Okay, is this an underestimate or an overestimate of the area under the curve? Well, we counted stuff that really isn't under the curve, so it looks like this is going to be an overestimate. In the previous two examples, we used the right endpoint of the interval to calculate the height of the rectangle. This yields what's called a right Riemann sum. We could just as easily have used the left endpoint, which would have given us a left Riemann sum. For example, estimate the area between the graph of f of x equals square root of x plus 3 and the x-axis for 1 less than or equal to x less than or equal to 6. Use a left Riemann sum with 5 equal subintervals. Give an answer accurate to 3 decimal places. Everything's the same except now we're doing a left Riemann sum. Okay, so in this case, we want to estimate this area. And let's go ahead and calculate this. So we're using left Riemann sums. That means the left endpoints of the interval gives us the height of the rectangle. So we end up with this. Because we're going to the left endpoint of each interval. Whoops, sorry. Because we're going to the left endpoint of each interval to calculate the height of the rectangle. Okay, so the height of this first rectangle is going to be f of 1. And as before, the width is delta x. So the area of this first rectangle is f of 1 delta x. Same thing, this will be f of 2 delta x, etc. This last one is going to be f of 5 times delta x. Factor out the delta x, we get this. Evaluate these at f of x equals square root of x plus 3. That's what we end up with. So we end up with 1 times root 1 plus 3, which is root 4, and that's 2. We end up with 1 times 2 plus root 5 plus root 6 plus root 7 plus root 8, and that works out to be 12.160. Okay, the grid points as before, 1, 2, 3, 4, 5, 6. Is this an underestimate or an overestimate of the area under the curve? Well, notice we did not count things that should have been counted. So this is going to be an underestimate of the area under the curve. Now, let's say we don't have a formula. Let's say I just give you a graph. Estimate the area between the graph of y equals f of x shown here and the x-axis for 0 less than or equal to x less than or equal to 1. Use a left Riemann sum with 5 equal subintervals. Okay, here we've got this. So let's go ahead and calculate this. So we got a left subinterval, a left Riemann sum with 5 subintervals. So here are what our rectangles are going to look like. Okay, and we end up with this one here. Maybe like that. Okay, the area of this first rectangle is going to equal the height, which I'd say is about 1. I'd say the y-coordinate there is about 1. And the width, well, the whole subinterval is 1, and there are 5 equal subintervals, so it's going to be 1/5. That's what delta x in this case, 1/5, in other words, 0.2. Okay, so it looks like this first rectangle is going to be f of 1 times 0.2. That'd be about 1 times 1.2. The height of this second rectangle, oh, well, let's say, it's going to be f of, the height of the first rectangle is f of 1. The second one's going to be f of 0.2, f of 0.4, f of 0.6, and f of 0.8 maybe, something like that. Okay, so we end up with this. Factor out the delta x's before, we end up with this sum. And now, let's estimate f at these values. F of 0, I'd say, is about 1. F of 0.2 is a little bit more than 1, maybe about 1.05. Because if this is 2 and this is 1, it'll be 1.2, 1.4, 1.6, 1.8, etc. So, yeah, I'd say that's about 1.05. F of 0.4, it's about, I don't know, maybe about 1.22. F of 0.6, that's about 1.54, and f of 8, that's just a hair more than 2, maybe about 2.03. We end up with 0.2 times 6.84 equals 1.368. And again, I'm just eyeballing it. I'm just guessing, folks. Now, if I had given you a table of values instead of a graph and asked you to estimate, the answer would have been the same. So suppose I give you this problem. Using this table of values, estimate the area between the graph of y equals f of x and the x-axis for 0 less than or equal to x less than or equal to 1. Use a left Riemann sum with 5 equals subintervals. So again, instead of asking you to estimate what these f values are based on the graph, I'm just telling you what the f values are. But it's going to be the same problem. Okay, so you've got this table, and you calculate f of 0 delta x plus f of 0.2 delta x, etc. You're just going to end up with the same answer, 1.368. The only difference is that I tell you what the values are, and you don't have to guess them.